All right, so this is number 87 out of chapter 2.3, page 129. So in this case, or in this problem, they again want us to go ahead and find the zeros. Okay, and they give you a graph in the book. I went ahead and I actually graphed it myself as well because I didn't particularly like the graph in the book. I thought it was a little confusing. And so this will help guide me. But one of the things that you can kind of see here is that we're having, we have one here, or one of our zeros looks like it travels through x equals 1. This one over here looks like it's, it's somewhere in between 3 and 4. And then this one here is somewhere between 0 and -1. So before I get started with anything else, I actually am going to take a look at the rational zeros using my rational zero test. So I can eliminate some of the, or I can get an idea of what these values should be. Now, I could also cheat and take a look at my table, but the rational zero test can give me a really good idea of where I should be looking. So again, the rational zero test, you take the factors of the constant, okay, in this case, which is -1. So I'm going to take those factors, and in this case, since it's just 1, that's going to go right there, plus or minus 1. Okay, and that's going to go over the top of the factors of the lead coefficient. If you need another example of this, we went through the same process in number 51, which is also up online. And this one here, it's 2. So 2 has the factors of plus or minus 1 and plus or minus 2. So that leads me to the conclusion, let's set my calculator over here, that the possible rational zeros we can have is 1 over 1, so plus or minus 1, and 1 over 2. So plus or minus 1/2. So looking back at my graph, and again without cheating by looking at the table, I know that the only possible answers I could have here that work, this one obviously cannot be rational. So the only ones that I can come to the conclusion is -1/2 is a possibility, and 1 is a possibility. So I'm going to try those out. Again, I have a 4th power here, so I need to at least get 2 of my rational zeros before I'm going to be able to factor. Okay. So again, going through my process, I'm going to choose x equal to 1 and -1/2. You can start with whichever one you want, but we're going to use synthetic division. Again, here we can go and choose 1 just to start. And I take 2, -9, 5, 3, and -1. We don't skip any of the powers, so I don't need to place any zeros in here to hold a place. Okay, drop down the 2. 1 times 2 is 2. -9 plus 2 is -7. 1 times -7 is -7. 5 minus or plus -7 will give me -2. 1 times -2 is -2. 3 plus -2 is 1, and 1 times 1 is 1. -1 times or plus 1 is 0. Okay, I have a remainder of 0, so I know that this is a 0. So I'm in good shape there. I verified my result. Now I'm going to go ahead and try out -1/2 and see if I can get a bit farther here. Okay. So I drop down my 2 once again, -1/2 times 2, and I'm just going to kind of go through this as -1. Then we get a -8 here, +4, -2, +1. Get a, no, what did I do wrong? -1, or +4. Oh, yeah, this should be a +2. My mistake. -2 plus 4 is +2. Negative, and that's what happens when you rush, right? -1/2 times 2 is -1. There we go, and we get a 0 here. Okay. Now I know that I have 2 of my zeros. Okay. And in this particular case, I am down to my quadratic, so I can simply take that I want to know when 2x squared minus 8x plus 2 is equal to 0. Okay. Now, I already know that these, from my graph, that these were my only two possible rational zeros. And if you want to go ahead and do your big X, you're going to find that you cannot factor this because these are not rational zeros. Again, the only possible rational zeros were plus or minus 1, so 1, negative 1, 1/2, and negative 1/2. We saw in the graph that these were the only ones that worked or were possible. So I'm going to have to use the quadratic formula. So I say X is equal to negative b, so negative 8, plus or minus, and I can label these here for you, a, b, and c, plus or minus the square root of b squared minus 4 times a times c, and that's going to be all over 2 times a. Okay, do some simplification here. Okay, I get 8 plus or minus square root of 64 minus 16 all over 4. Okay, come back over here to finish this up, and we're going to get 8 plus or minus the square root of 48 over 4. I can rewrite this as 8 plus or minus the square root of 4 times the square root of, I can do even better than that, can't I? You could do it that way, but you'll find that you can reduce even further. So I can do the square root of 16 times the square root of 3 all over 4. Okay. And that leaves me with 8 plus or minus the plus or minus 4. The square root of 16 is 4 square root 3 all over 4. I can then cancel the 4 here, and I get a 1, and here, and I get a 2. And the final answer would be 2 plus or minus the square root of 3. Okay, so I have two solutions here. I have 2 up here, giving me the 4 that I would expect from my big power at the beginning. And again, since it's simply asked for the zeros, we can go ahead and write those in set notation. X is equal to the set of negative 1/2, 1, and then 2 plus or minus the square root of 3. And those are your zeros. Voila!